Okay, Chem students, today we're going to be talking about atomic mass. You need your atomic nuclear notes, practice packet, and something to write with. Now, it's helpful for us to know the average atomic mass of all the isotopes of an element. And we can find that by a weighted average technique, which takes into account both the abundance of all the isotopes as well as their masses. Atomic mass is measured in something called AMUs, or atomic mass units. 1 AMU equals 1.660538 times 10 to the minus 24th grams. We're not going to deal with that. It's much easier to say 1 AMU. So the masses of all elements are compared to carbon-12, which is defined as having a mass of exactly 12 AMUs. Now remember, the atomic mass is the number on the periodic table that has several decimal places after it. This is the average of all of your isotopes. Okay, a good example of how weighted averages work would be your grades in this class. Now, major grades are worth 55%, minor grades are worth 30%, and other grades are worth 15%. So if you had an 88 average on your tests, you have two tests and we average them. You have an 85 average on your quizzes. You do pretty good on your quizzes and labs. But you have a 24 average on your homework because you don't like to do it. We're going to calculate out what that is. So we change the percent from 55% to 0.55, 30% becomes 0.30, and 15% is 0.15. We're going to multiply all of those times the grade. So major grades, 0.55 times 88 is going to get me 48.4 points. Minors give me 25.5 points. Other grades only going to get me 4.5 points. So when I add it up, my weighted average is a 78.4. Now let's try to see, for an example, what would happen if we change those homework grades. Let's say you do most of your homework. You only forgot one time. You have an 84 average now for your homework and other grades. That would change your weighted average to an 86.5, which rounds up to an 87. That's almost a 10-point jump. So you can see how a weighted average works, and you can also see the benefits of actually doing your homework and not totally blowing it off. Now, we do the same thing for determining average atomic mass. The weighted average technique means we take all our isotopes, which I have here, neon 20, neon 21, and neon 22, and I have all of their abundances listed. So I'm going to convert this to decimals. So 19.992 is the atomic mass for neon 20. Multiply that times 0.9051. See how I got rid of the percentage? And that's going to give me 18.0948. I do the same thing for neon 21, which is 20.994 times 0.0027. It gives me 0.0568. And lastly, neon 22, 21.991 times 0.0922. That gives me 2.0276. So the weighted average is determined based on their abundance in the world, how much each contributes to the average atomic mass. At the end, these three numbers I'm going to add up, and it's going to give me 20.1792. Now that is actually almost identical to what is on my periodic table. So 20.18 to round it up. Okay, that's how you do average atomic mass and weighted averages. Go ahead and do the pages that correspond in your practice packet. We'll see you for the next video.